Hello everyone, I am Sharat Chandra V. Welcome back to my ANSYS tutorial. In this video, I will be solving stress analysis of a rectangular plate with a circular hole at the center of the plate. This is the figure that is having a rectangular plate and a circular hole at the center of 10 mm diameter, and a tensile force of 2000 Newton is acting along x direction. And we have Young's modulus of 210 GPa, and thickness of this plate is 1 mm, Poisson's ratio is 0.3. Now we have to convert this force into pressure in order to solve this in ANSYS. This is the calculation we have to do to find the pressure. We know that pressure is equal to force divided by area. We have the force 2000 Newton and area 40 into 1, that is 40 mm height into 1 mm thickness, that is the area for this rectangular plate, that gives 50 Newton per mm square of pressure. Now we have to find the nominal stress. We have the formula F divided by W minus A into T. This formula is in data handbook. W represent the thickness of the plate, the width of the plate, that is 40 mm, and A represents diameter of the circle, that is 10 mm, and T is the thickness of the plate, that is 1 mm. So we get the nominal stress as 66.66 Newton per mm square, and stress concentration, we have the formula sigma maximum divided by sigma nominal, that is maximum stress by nominal stress. This K sigma can be found out from the data handbook. For this we have to find D by W ratio, that is diameter of the circular hole divided by width of the plate, that is 10 mm divided by 40 mm gives us 0.25. For that 0.25 from the graph in the data handbook, we will get K sigma as 2.5. If we substitute these values, then we will get sigma maximum is equal to 166.6 Newton per mm square. Now let us check these answers in ANSYS. Go to ANSYS workbench, click on preferences, structural, H method, click OK. Go to preprocessor, element type, add, click on add, select solid, quad 4 node 182 and click OK. Now go to options. Here in the drop down menu of K3 value, select plane stress, width or thickness and click OK now. Now close this tab, go to material models. In material properties, first you have to assign a thickness value in real constant. So go to real constants, click on add, click add now, click OK, give the thickness value, that is 1 mm and click OK now. Close this. Material properties, material models, click on structural, linear, elastic, isotropic. We have the Young's modulus 2.1 exponential 5 and Poisson's ratio of 0.3. Click OK now. Close this. Now go to modeling, create areas, rectangle by dimension. Now we have to create the rectangle using dimensions, and we know that the dimension, now we are creating only 1/4 of this rectangular plate, that is this much portion only. So for this the dimension is 30 mm and 20 mm, 30 mm along x direction and 20 mm along y direction. Now go to ANSYS workbench, and if the tab is hidden, click on this raise hidden button, you will get this. So we have to give the coordinates. For x1 we have 0, 0, and for this one we have 30 and 20. Yes, we have 30 and 20, and click OK. Now we will get a rectangular plate like this. We have to create a circle from origin. Now go to circles, here solid circle in origin, that is x at 0, y at 0, and the radius of the circle is 5 mm, and click OK. Now we have to eliminate this portion. So now go minimize this create tab and go to operate, booleans, subtract, areas, select rectangular plate first and click OK, and now select circular plate and click OK. Now you may see this deleted portion. Now go to meshing, mesh tool, click on mesh, select this plate and click OK. Now we have to refine this meshing, so again go to mesh tool, select refine here and click pick all here and give the minimal as 3, or you may give it as 4 and click OK. Now so now you can see the refined mesh. Now go for loads, apply displacement, symmetric BC. We have to take symmetric BC here on lines, this bottom line and left line, select those lines and click OK. Now the boundary condition is applied. Go to force on line, go to pressure and select on line, select the right portion and click OK. Give the value, that is we have calculated here. We have got the pressure 50 Newton per mm square. Give 50 as the value for the pressure and click OK. Now but it is acting in opposite direction. If you got wrong like this, just go to delete, select pressure here and click on lines, select this line and click OK. Now the pressure is deleted. Go to apply loads, structural and go to pressure on line, select this line again and click OK. Change the sign, it is minus 50, click OK. Now it is acting as a tensile pressure. Now go to solution, solve, current LS, click OK. Now the solution is done. You can see the results now. Go to post processor, plot results, contour plot, nodal solution, stress. Here select 1 minus stress and click OK. You can see the value, that is 162.404. that is similar to the result that we got in analytical method, that is 166. It is approximately equal to 166. And now if you want to see this as a full rectangular plate, go to plot controls, here select on style, symmetric expansion, periodic or cyclic symmetry, and select this 1/4 dihedral system and click OK. Now you are seeing at the rectangular plate as in the figure itself. If you want to see the thickness for this, just select isometric view here, go to plot control, style, size and shape and display of elements on, click OK. Now so this is the thickness of the plate, and if you want to animate this, you can animate. Go to plot control, animate, deformed shape, deformed plus undeformed, click OK. Now you can see the deformation in 10 steps. Okay, thank you for watching my video. If you like my video, please subscribe, like and share. If you have any suggestions, feel free to comment. Thank you.